Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Alhamdulillah rabbil alamin wassalatu wassalamu ala asrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Our beloved keynote speakers, so it is now time for our second keynote speech by a very well-renowned keynote speaker. Even introducing himself, just by his name, people already can associate his expertise, which is in membrane. And Professor Ahmad Fauzi, I've known him for quite a while, maybe more than 10 years back, while we were together in the Encyclopedia Committee for Dewan Bahasa and Pustaka. So, it is a great pleasure for me to just read out to you a brief. This is a very brief one because I believe the list of awards is numerous, it's too many. Okay, so our second keynote speaker is Professor Dr. Ahmad Fauzi Ismail from University Technology Malaysia, UTM, Johor. Professor Fauzi holds a BSc degree in Petroleum Engineering from University Technology Malaysia in 1989. And master's degree from UTM in Chemical Engineering in 1992. In 1997, he obtained his PhD from the University of Strathclyde, United Kingdom, under the Association of Commonwealth Universities Scholarship. And throughout his career, he has developed deep interest in membrane technology. Today, he is one of the Malaysian experts in the field which include the membrane manufacturing technology, membrane process, and membrane process modeling and design. He is also deeply involved in the development of carbon monotube for hydrogen storage for fuel cell applications. His continuous efforts in R&D has awarded him with more than 60 awards, nationally and internationally. Among them is the UTM Researcher of the Year 2000, ASEAN Young Scientist 2001, UTM First Prominent Researcher, Tokoh Penyelidik 2008. In 2009, he received a grand prize winner for National Intellectual Property Award Patent category and National Innovation Award Waste to Wealth category. His research outcome has also given him the best of the best invention awards at national level, twice. Currently, Professor Fauzi is the Editor-in-Chief of Applied Membrane Science and Technology Journal, Editorial Board Member of Desalination Journal, Membrane Water Treatment Journal, and Journal of Rubber Research. He has published more than 240 papers in high-impact journals and refereed conference proceedings. Professor Fauzi is currently the head of the Advanced Membrane Technology Research Center, MTech, and the Executive Director of Materials and Manufacturing Research Alliance in UTM. Without further ado, it gives me great pleasure to invite Professor Ahmad Fauzi to deliver his presentation entitled Membrane Materials for Advanced Separation Process, Current Challenges and Future Prospects.
Assalamualaikum and very good morning. And I would like to thank for the kind introduction by my colleague, Dr. Khalid. And first of all, I would like to take this opportunity to thank the organizing committee for the kind invitation. And this is my third time in the UTHM, but in a different capacity. And today I'm going to talk a little bit technical. Last two visits is more about the general about R&D. And I was asked to talk about advanced material, but I have to mention to all of you that I am not actually the real people in advanced material. We are only mix and match whatever available in the field. Then we do some innovation, we do some invention, so that this innovation and invention product would then transform into products that may help, may contribute to the community, to the country, and of course to our stakeholders, because we receive lots of money from them and we are really responsible, accountable for the outcomes. That is the most important things. And today I was asked to talk about material, because NAME is about material and manufacturing. And it so happened that I'm involved in charge of material and manufacturing in UTM. Yeah? So, across my presentation you will see that even though people know me about talking about membrane all the time, since the first day I'm involved in R&D, people know me about membrane. But in fact, in 1990, I don't even know what is membrane. You know, asking around people in UTM, what is the meaning of membrane? Because my background is petroleum engineering, or in Malaysia, they call it orang minyak. So, to be acquainted with material like membrane, of course, it is very, very naive for me at that time, right? Just bear with me that I am not mechanical engineer. I am, half-hearted chemical engineer, and I am one foot in material engineering. So so-called I am master, what do you call it, master of trick, expert in nothing. Right. This is some outline of my presentation. This presentation is actually a collection of what has been done or ongoing in my lab. Yeah. So I will share with you, all of you, about what we have done in our lab in the last 10 years or so. Yeah. About the membrane technology, about the gas separation, about zeolite, carbon nanotubes, and gas-liquid separation, membrane contactor, liquid-liquid separation, hybrids membrane, again, material, fuel cell, polymer membrane materials, and challenges and future outlook in this technology as a whole. Now, as an introduction, let me brief you about the importance of separation processes. Membrane is actually part of the worldwide separation process technology. So far, 70%, yeah? So far, about 30%, yeah, to 70% of the capital cost goes to separation processes worldwide, regardless of the technology being employed. 30 to 70%. Yeah? Many people knows about distillation, absorption, pressure absorption, temperature absorption. All these are considered separation processes. And it consumes up to 70% of the capital cost. And it is estimated that about 5% of the total energy consumption in the United States and Canada is attributed to the separation processes, energy. Mind you, in the RM10 coming soon, energy research going to dominate. This is the clue that given to everybody. I'm just delivered to you. For those who would like to capture lots of fundings, please get involved in energy-related, material-related energy, for energy application, for example. And industries using separations include commodity and specialty chemical, such as fertilizer, pulp paper industries, biotechnology, microelectronic, pharmaceutical, and so many things, including drinking water. why I stopped at drinking water. Just adjacent to this university, there's a water treatment plant, right? Parit Raja water treatment plant. Siapa tak nak pergi? And you know what is the pH fed into that treatment plant? 2.8. And you are all here are drinking the 2.8 fed water to the treatment plant. And I was given the task by the Johor State to evaluate. 2.8 pH to the treatment plant, and as a result from that, you are drinking, not here, at home. So imagine, tak ada seekor ikan hidup. The major separation processes based on absorption, adsorption, crystallization, distillation, extraction, and lastly, membrane technology. And last, when I started research in membrane, way back in early 1990, this technology not even in the textbook. Not even in the textbook. And people are cynical about this technology. Fauzi, why you do this kind of study? The technology not even in the textbook. So I was a bit down. So after thinking for a while, I said, the technology which were in the textbook is a sunset technology. Whereas the technology that has not been yet in the textbook is a sunrise technology that made me a bit happier. Yeah? Same thing, those who are in the museum is already the past. Now, why membrane? Why people talking about membrane? Maybe in UTHM there are few active groups like Dr. Zawati, and going to soon to be my student, going to be Dr. Madia Hatijah, is also doing membrane. Many people ask, why you do membrane? You know, membrane is actually not new. Membrane was started, the phenomenon in 1860, 1850. But that phenomenon stayed as a phenomenon. It's not been used for commercial purposes until 1920 in Germany. They use it for bacterial separation. Not until 1950s, 60s, where it been used for water treatment and treatment of kidney failure. You know, people are talking about hemodialysis. Dialysis, the heart of that system is a membrane, actually. Okay? High stability. If you are producing ceramic membrane, glass membrane, metal membrane, very stable. Low cost and capital. Yeah, 10 years ago, yes, it is very expensive, like fuel cell car. But in the next 5-10 years, fuel cell car will be flooding the market in the world. High efficiency. For example, fuel cell car. Our car now operating maximum efficiency is about 30%. Fuel cell can goes up to 80%. And heart of fuel cell system is a membrane. Mechanically, robots, if talking about ceramic membrane. And ease of operation. People last time talking about hand-on, hand-on. Membrane, hand-off. Everything automatic. Right. Low energy requirement. We only need one pump. The rest are stagnant. If you are using distillation, energy consumption, vibration, you know, and lots more to be included. That's why people all over the world, before in America during George Bush era, is pumped $1 billion USD for the development of membrane fuel cell. Now, membrane fuel cell become a phenomenon, R&D worldwide. Now, scientists and engineers are often fascinated about membrane by the fact that delicate structure, 0.1 micron. thickness that do all the magic separation processes. We are not talking about very thick, 0.1 micron. Yeah? Make it possible to carry out industrial separation process. This is where people, engineers, the scientists are really fascinated. And you know, the best membrane in the world is in our body, our kidney. There's no spare part. You know, since the birth until today, you go to any hardware shop, no spare part, brother. No spare part. So be very careful. Now, just to give you an overview of application of membrane and why people are now concentrating their efforts toward developing this viable technology. Because number one, of course, people talk about business. The business in membrane technology are lucrative. Yeah? Multi-billion. Because it spans from industrial, petrochemical, environment, and medical. When you go through all this list, then we know every day we are dealing with membrane. Yeah? I don't need to go one by one. There's so many. Now, I've done this quite a number of years ago when we do it for MTDC. Yeah? So this is an overview of the application in Malaysia. This is for what biotechnology. So it was way back 5 years ago. It is expected now to push up to about 1,000, which is about 1 billion. You see? Ultra pure water, drinking water, dim-light water. You know that this water that I'm going to drink is more expensive than the oil. It's 500 ml. It's cost you 1 ringgit something, right? You go to the petrol station, 1 liter only 1 ringgit 80 cents. So if this becomes 1 liter, it becomes 3 ringgit. So the water is much more expensive than the oil. Betul tak? Betul lah. Okay. For food, it is expected 5 years ago about 700, 800 million in Malaysia alone. Ringgit, of course. Yeah? Palm oil industry, we're going to be the dominant player. And medical and pharmaceutical, still very new in Malaysia. You know, in Malaysia we have B. Brown in Penang, who manufacture that. You know. And then quickly, it's the world market. The world market in 2010 is estimated to be 350 million USD. Yeah? But in 2020, it's going to be 760 million. And the average growth rate is about 7 to 8% per year. It's very, very, very high for such a very new technology. Let us see about this. So when people would like to do research or do some business in this technology, you have to have like a lifetime's forecast, projection. We don't do research for the sake of sok sendiri. You know, self-shock, self-pleasure. We have to have this kind of projection so that whenever you are graduated or whenever you would like to embark into a business life, inshallah you are not going to fail. Otherwise, it's a big problem. So what you need to do, you can see that they are down there, the x-axis, development phase, growth, high sales phase, and sales declining phase. And that is the sales, the value or the volume of sales. So, whoever would like to develop immunoisolation, which is in biotechnology, this is the upcoming. Whoever would like to do hemodialysis, the technology is already matured. Now, people are planning to look into this planning to look into this area. Yeah? This is the area of interest. Petrochemical industries, food and beverages industries, they are looking into gas separation. I just include their membrane contactor. It's very new, but very lucrative. And ultrafiltration in food and beverages industries, water and wastewater treatment, and so forth. And of course, gas separation becoming very, very popular nowadays. So what are the development right now, yeah, in order to improve materials? First, development of high-performance nanocomposite reverse osmosis. Which means, afterward I'm going to tell you about the merit between polymer and inorganic material. How are we going to do that? Preparation of advanced mixed matrix. This is a word in membrane technology where we mix, or we disperse inorganic material into the homogeneous polymer material. So we call it mixed matrix, which is actually similar to the nanocomposite. Adaptation of rheological factors in membrane production. Rheology, mechanical engineer also learn about rheology. Rheology is extremely important. I got PhD in rheology. By studying rheological factors in membrane, I got my PhD. And development of advanced material, polymer blending, is a huge area to study in order to improve this material. Separation of plasticization polymer material. Plasticization means the change of structure, yeah, due to the presence of some other component, like if in gas separation is a polar gas like CO2, which will alter the physical structure of the polymer, swell, and a lot more. Now, these are some of the methodological approach in order to develop the whatever technology, not only in membrane. What we have done now is shortcut, a lot of shortcut. Shortcut will lead to short circuit. We do some synthesis, suddenly we were asked to do system design. We only have done characterization, suddenly we were asked to sell the product. Ya? Apa yang berlaku kepada kenderaan kita sekarang? Jenama kita? Itulah dia. We just in the production scale, we were asked to do the field test. That's why, in order for certain technology to be fully acceptable commercially, you have to complete the cycle. This cycle must be completed. Otherwise, you got a product sell, yes, but you cannot sustain. Because like computer, within 3 months, development is very rapid. That's why all these need to be completed. Whoever expert in process design simulation, do it. Collaborate with those who have, expertise in characterizing, manufacturing, testing. Collaborate with those who expert in material characterization, and of course, synthesis. Collaborate with chemists. They are no better. And now come to the membrane itself. The membrane is actually very simple. It's an interface between the two phases, which allows certain component to pass through and retain the others. Very simple. And you go back and check. Go back and check in the Holy Quran, Surah Al-Furqan, verses 51, 52. Allah Ta'ala said that in the Quran. And Surah Ar-Rahman, verses 19 to 21, if I'm not mistaken. Go and read. This technology was mentioned in the Holy Quran. Yeah? This is how it's worked. Only allow certain components to pass through and retain the others. So, the performance will be determined by how fast it's allowed that component to pass through, which is called flux, or permeation rates, or permeance, and how efficient the membrane retain the other component, which is called selectivity, which is the ratio between the fast gas to the slower permeating gas. These two parameters determine membrane performance. Very simple. Anybody can get PhD masters within specified time. No problem. Come to my lab. And of course, there are a few separation mechanisms that involve in this reveals technology, I call it, because it's in, there are many more in the Quran, yeah? Some call Knudsen diffusion, yeah? Some call molecular sieving, some call solution diffusion, which occur, for Knudsen diffusion, the separation occurs along the narrow, long pore due to frequent collision of molecule with the wall. Whereas molecular sieving, based on the much higher diffusion rate of the smaller molecule, absorption capacity is important in this case, and solution diffusion based on solubility and diffusivity. That's why in some processes, it does not depend on the size. Say for example, CO2 gas, is much bigger than methane. But methane is permeated through the membrane faster than, CO2 permeates through the membrane faster than methane. It's because of the solubility is higher. Now we come to the mixed metric. How we develop mixed metric membrane material, which is now is a booming research area in this technology. So how we do that? The mixed metric comprises of inorganic entities embedded in a polymer metric to obtain promising selectivity, which, in other words, using adopting easy processing polymeric material character with the high selectivity molecular sieving effect of the inorganic filler, like zeolite, carbon nanotubes, carbon molecular sieve. So we mix that. So mixings occur during synthesis. It's very simple. You prepare polymer solution, you add on zeolite, and you stir. That's it. Very simple. And why we develop this? This is because suitable for harsh environment. Polymer cannot be used for temperature more than 60 degrees C, even though the TG is about 180 or 200. But to get it done better, it must be operated below 60 degrees C. So that's why we develop mixed metric. Another one is the lifespan of the membrane. Polymer, very short. The highest, maybe 3 years. And permeability and selectivity trade-off. The higher the permeability, the lower the selectivity. Meaning that the faster all of you coming into this room, the less selective the guy or ladies in front who are going to entertain you, right? Lagi cepat masuk, lagi susah kita nak bagi ini first class ke, second class ke, tak ada kelas. If you come into this room slowly, meaning that the selectivity is very high. That means the trade-off is always, in polymer. Now, to avoid, to take advantage of these two areas, polymer and inorganic, so what we do? We married them. We force married them. Nak kahwin lebih pun tak apa. But this one, forced married. We take only the advantage of the two different areas. We married them and become a superior material. That's called mixed metric. However, because of the forced marriage between the polymer and the inorganic material, there are a lot of challenges. I don't like you, you don't like me. what happened? When you marry these two, there is always some form of defects occur. And this defect called sieve in a cage phenomenon. So when we subject this material for any separation processes, say for example, a gas separation, the gas will pass through a few channels. One, through the polymer, through the sieve, and through the bypass through the defects. So at least 3 channels. So this is a challenge, how to solve this problem. How to create defect-free. Yeah? And another one is plasticization. Plasticization means the enlargement of the polymer structure, stretching. If polymer structure stretch, the water or the gas easily pass through, no selectivity. So these have to be solved during the synthesis. Another filler calls, and these are the fillers that normally being used. Zeolites, that is a common structure, and carbon nanotube, like a tunnel. These two are very important and cutting edge, especially the carbon nanotubes. People talking about carbon nanotube. Have you seen carbon nanotube? No. Go to my lab, we produce it for you. Now, zeolite we use because of thermally stable, withstand high temperature, chemically inert without harsh operation, and possess molecular sieving characteristic. Molecular sieving characteristic is very important. It's why we use. And the separation mechanism in zeolite is based on these 3. Yeah? So, some of these mechanisms are undesired. But we can compromise by including polymer. That's how we married these 2. Another one is polymer zeolite. What the outcome of this marriage between polymer and zeolite are homogeneous polymer and zeolite matrix which enhance gas selectivity. So we do this and we publish some selected publication, quite recent one. So in order to reduce the defect just now, we add silane agent, yeah, to modify as a cross-linking agent. Carbon nanotube, you can see the diameter, the outside diameter, 17 nanometer. The inside diameter, 6 nanometer. And we produce multi-wall, which is about 16 layer. Yeah? And the thickness is 5.6 nanometer. Remember, everyone can produce this. If I am from petroleum engineering, can produce this. From mechanical engineering, should be double the capacity. Right. Why CNT? Carbon nanotube. High aspect ratio. Inner tube diameter for dimension control. We can control. Simple functionalization and dispersion in organic polymer. Mechanically strength with smaller filler content. And high surface area. This is important. The smaller, the higher. Like Professor Hafiz. The smaller, but very high. This is some of the machine that we design and we fabricate in the lab. And we produce our carbon nanotube using this machine. Yeah? We have 2, one called catalytic chemical vapor deposition, very simple one, just a quart tube with this furnace. We grow the carbon in the tube. From that, this is we can produce, but it's a bit unpure. So in order to produce purer material, so we design and fabricate what we call plasma enhanced chemical vapor deposition system, purer products. We produce that. Okay. The machine is in the lab. So during the preparation of carbon nanotube is very hydrophobic, and then if you want to marry it with the polymer, you need to massage it, you need to functionalize it so that you can have the face of carbon nanotube can take the polymer. And then, if possible, this is our dream, yeah, to have carbon nanotube in very aligned manner. The carbon nanotube is a bit random, yeah. So we are going to produce aligned carbon nanotube in polymetric in the future. This is the dream of every researcher and scientist involved in this area. Now, this is the transport mechanism, yeah, in the carbon nanotube mixed matrix. So by having mixed matrix, and with the capacity and the ability of the carbon nanotube, it distinguishes better between the desired product with the undesired products. Yeah? Now, the sum of the performance data that we got from the lab, you can see that here. You can see that this is never mind. The upper one is for CO2, yeah, and this one for methane, and this one the data without CNT. Huge improvement. So you can see clearly here, this is the selectivity of the functionalized multi-wall carbon nanotube mixed matrix membrane compared to the rest. You can see the huge improvement in terms of membrane performance. But what are the challenges here? You know how to produce, you know the characteristic of each material that you want to use, but polymer undergo a trade-off limitation. High permeability resulted in low selectivity. So this limitation is the ability to withstand high temperature, aggressive environment. So how to overcome this? This can become a research topic. Yeah? Development of a new membrane material, we can withstand high temperature and aggressive chemicals. Improve material to develop robust membrane to meet the key criteria of reliability and durability for industrial application. And to improve engineering design, supramolecular membrane morphologies, and economical module molecular design, molecular dynamic simulation. For those who really expert would like to study from molecular architecture. So these are areas that we can go to. Next, liquid-liquid phase. Yeah? Liquid-liquid phase separation, hybrid membrane. So, the process is already established. Recently deployed processing and emerging technology. Produce water or wastewater treatment. This, not many people involved. But if you know the potential, if you get close with the industries, with the oil and gas industries, you might be immediately attracted to this. Imagine in the oil and gas platform, every day they drills. They use mud for drilling, water, and after that, all this mud and water will just discharge to the sea. And now DOE, environmental, DOE imposed very stringent criteria for disposal of this produced water. And when equipment, when the system offshore, you just name the price. You just name the price. Yeah? So last night, I had a very fruitful discussion with one of the oil giants in the world, addressing this produced water. Just name it. But you must prove it, that you can. Oil and gas, they pay you top money, but they expect top technology. Otherwise, they will cut throat. Now, these are the emerging technology. Emerging means you can still get involved heavily. And inshallah, no problem, you're going to be an expert, well-known in this area, which called reverse osmosis and electrodialysis for demineralization of produced water. Second, chemically enhanced ultrafiltration for improved removal of soluble oil, dye, microbial colonies of bacteria. And the technology contributes to its increasing recognition as a reliable technology for cost-effective production of high-quality, affluent, and social challenges based on intense regulatory activity. If you don't believe me, you go to Sembrong Barat. Dekat sini Sembrong. Those who know Sembrong, you go Sembrong. I've done some study, some plant audit there. No wonder this area called air hitam, because the water is really hitam. Yeah? You go there. I've done, my report is about that thick. And this is some of the system that we developed in the lab. Okay. This one, this one for, ini Hatijah punya lah, Hatijah, you punya. Okay. That one for submerged membrane bioreactor. So all of my students, my staff have to develop their own system. They test their own system, produce their own data, publish their own data. Otherwise, no PhD, no master. Now, this is some of the electron microscopy images of the membrane, our membrane. Yeah? So modification in membrane metric by addition of inorganic compound, titanium oxide. Yeah? So UTHM student conducted this. Yeah? And this is the data. You know, just recently published in Desalination. Not because I'm the editor of the board, but the quality of the paper. Okay? So we got 98% rejection of impurities. And higher fouling resistance because of the insertion of the titanium, the filler just now. And small footprint, very small. Very small. And lower energy consumption. I mentioned just a pump, just one pump. Yeah, one pump. Just one pump there. Very small pump. The only one. Okay. Now this one, antibacterial or antibacterial membrane. Now this one also by one of your students. Surface, what we do with this? We modify the surface. We modify the membrane surface by addition of antibacterial agent just to improve the mechanical and separation properties. And we develop that material, we test that material, and you can see from there, there's a lot of bacteria here. Betul tidak ya? There's a lot of bacteria there. You can see after the filtration. No bacteria at all. Adalah 2 kerat, 3 kerat. So we prove that with electron microscopy. Now, having said that, there are a lot of challenges. In water, wastewater treatment, a lot more challenges than gas. Because we do not know what is inside the water. There are so many compound there. Yeah? So, RO will continue to be the playing a major role in water treatment, yeah, which employing nanofiltration and RO, maybe, yeah, as a powerful tool, yeah, for reading water to those micropollutants. And the two key challenges, yeah, membrane fouling. Fouling means the accumulation of the unpermeated compound. When we pass through the feed, some permeate through, some don't. The don't one, as a factor of time, will be accumulated and become a cake layer. And that's called fouling. Yeah? Elevated energy, the process required. The possible area of improvement include membrane material, module, and system to effective scoring and low membrane fouling rate. This can be another PhD study. Yeah? And microbial contaminant represent a major concern in water reclamation, and membrane can provide physical disinfection. And how are we going to do that? Conduct a study. And we got few companies interested in this, and we are in a negotiation period. And challenges is develop a membrane that able to filter out viruses and imperfections that allow leakage. Yeah? Now, membrane contactor. Maybe not many people know about this contactor, but we have developed rapidly in the lab. Yeah? Why contactor? First, high gas liquid contact surface area, low cost and capital, very high selectivity, high driving force at low pressure, independent control of gas and liquid flow, and low energy requirement. How we do that? You can see that. That is the membrane, the PVDF membrane. This material can withstand high acidity, high acidity, PVDF. Even the stainless steel cannot withstand acidity, but this material can. This can withstand hydrofluoric acid. Stainless steel can't. So we develop from this kind of material, yeah, and we develop the contactor there, up there. We put this material inside the module, and then we pump ionic liquid. Have you know about ionic liquid? Like ethylene glycol. You know ethylene glycol kat dalam kereta kita sejukkan enjin. Glycol, ethylene glycol, methylene, MDA, MEA, they call it. We put in, we pump into that, and this is a system. Yeah. So here, this is a graphic there. So what we do, we pump in solution into the lumen side. Lumen ni lubang dia. Allah. The blue arrow there. Yeah. We pump in the liquid. At the same time, we force the gas. So what it do? This is a porous membrane. This is a porous membrane. Yeah. This is absorption liquid, which is ionic liquid. Nama saja hebat, ionic liquid, but it's just like ethylene glycol, diethylene glycol, you know, triethylene glycol that used to absorb, yeah, used to absorb the bad gas. Where is my cursor? This is the bad gas, CO2. So CO2 pass through. This is the CO2 line here. CO2 pass through, liquid pass there, and this porous membrane, you know, this liquid will absorb CO2. So this is very, very simple, very economy, very efficient, very effective separation. And the way forward in membrane for removal of CO2, global warming problem, you know, this is the system. The system came from advanced material. Okay? So you can see that we develop the technology by using, we compare with, this is for the commercial one, the commercial available polypropylene, and this is a commercial available PTFE, lupa lama apa, no? And this is PVDF with glycerol. You see, our material, our membrane shows very high flux. Yeah? Flux means very high performance. And here, this is the structure of our membrane. You can see that very porous. Down here, porous means low resistance. Low resistance means high flux. With very high integrity skin layer, yeah? Very thin, to ensure the high productivity. But there are some challenges, not many. Yeah? Long-term stability of the membrane contactor upon contacting with CO2. Yeah? So it's very important. It can be affected by wetting of the membrane and interaction between membrane and the liquid absorbent. So in order to fulfill the long-term stability, the membrane contactor and commercialize the technology, there are about 3. Number 1, to be done, develop membrane structure and material. Second, liquid absorbent properties we need to find. So somehow we use water. Yeah? It's okay because I already patented it. We use water. Instead of any other chemicals, discharge, we just use water. And economical analysis of the technology. Now, fuel cell. Fuel cell car, fuel cell battery, lithium ion. This is why people use fuel cell. And fuel cell can be used to power this building, And this is how, okay. In terms of fuel cell material development, we use polymer. This is polymer. This is a method, reducing grafted. And this is our finding. And this has been published way back 2006 from our lab. So the yield, the grafting yield is about 46%. And we can reduce the permeability methanol, the loss of power, of energy, 71%. So this attracted Nissan Motor from Japan to come and discuss with us. And again, we developed that for PTFE, and the yield increased about 28, not much, but we managed to publish it. It was very, very early research, was way back in 2005. Yeah? Again, we keep on improving the material, and 2007 we developed SPIC, sulfonated polyethylated ketone, and we managed to produce 90% higher in terms of proton conductivity than the commercially available Nafion. Yeah? Again, we develop SPIC, we test again, and latest we develop SPIC in cooperation with titanium oxide. Sorry, SIWA we call it. Tungstosilicic acid, SIWA. So it was published last year, if I'm not mistaken. And this is very recent, last year. And challenges is to produce low gas permeability. That is, and must conduct proton and be a good methanol barrier. This is outlook. Yeah, just another 5 minutes. Potential and outlook for membrane technology as a whole. Number 1 is in fuel cell. Sorry, I just out of my mind. Number 2, natural gas separation. Number 3, recovery of hydrogen in a refinery. And number 4, production of oxygen from air. This is very, very important. Besides agricultural-based technology, where we use membrane to recover vitamin E from palm oil, and having said that, artificial organ. because I'm not involved in that, but people in Japan have done this. Now, last 2 slides. Let me share with you. This is so-called application development. First, you need to have very strong background, fundamental in engineering and science. Yeah? Characterization. Later, you move in developing a technology platform. Identify which technology that you would like to develop from the fundamental background. Identify the platform technology. Clearly, when we ask you why you choose this technology, because of this. Why this? Because, so and so have done that. We do not want to do this. Identify the platform technology. Now people are talking about pico, porous polymer. No more nano. People are talking about pico. Now after that, product and process technology development. After you got the material, you have to build a system, show it to the community, show it to the people, show it to the stakeholder that their money worthwhile. Otherwise, why should I fund your research? So having gone through this, then you become very successful researcher. Now, this is my last slide. The problem in certain technology, I'm talking about membrane technology, is the translation phase, membrane to the solution, or translation phase for any other technology to the solution. Why we have problem? Why we have problem in translating certain technology into the application? Because number one, we don't know the problem. Kalau tak percaya, the supplier came to us. We want this and this, and the supplier keep asking us, what the spec? Bagi je lah, mana-mana you rasa boleh. This is our reaction. So we need to understand properly the solution. Say for example, water. We have pH problem. That's a number one problem to be solved. Second, what membrane you want to use? Entah, I don't know what kind of membrane. What membrane you have? You ask us back what membrane you have. Meaning that you do not have the background of the technology or the background of problem to be solved. You don't know. Is it end pipe? Is it reuse? What equipment? What kind of equipment you want to use? You don't know. Everything don't know. That's why some of the system supplied to us used 2 years, kaput after that. This is man-made problem, not a technological problem. Feed spec, agak-agak 1 million lah. 1 mm standard cubic feet per day. Main agak-agak aja, just gas. Now, what material? The feed material, I don't know. Is it electrolyte? Or is it ionics? Or is it what? You don't know. What configuration you want us to supply you? The membrane. What you have. Last, the cost. If you don't know the problem, the cost might be enormous. Because of this translation problem to solution, we do not have. That's why in the very early stage of membrane technology, the penetration membrane into the industry, the membrane always have a bad reputation. And I have some experience, appointed by the government of Johor to do the study. And very, very bad. You go to Parit Sulong, how far from here Parit Sulong? 20, 30 kilometers away from here. You go there. Very beautiful water treatment plant, membrane based, operated 2 years only. And after that, kaput. And you know how much the cost? 10 million. Whose money? Our money. Why is like that? Because of this. And when we academicians would like to give some honest explanation to the problem, They don't like because they said, "Wow, you are intruding the area of my expertise." What is the area of your expertise? I don't even know. This is a big problem now. They do not know how to translate the problem into the reality. And at the end, membrane is not good. Distillation is not good. Any other technology coming to our country is not good. And what is good? Buat duit untuk dia orang. Now, I don't want to do that. Then, that's it. The end of my presentation. Thank you very much.